Action. Partitioning a line segment. I'm going to read this over, y'all. Hold on, I'm going to go fast, though. To partition a line segment means to divide a line segment into a given ratio. The two numbers in the ratio must add together to equal the total number of pieces. Like I said up here already, the three ways you can write the ratio with a colon, 1 to 3, 1, 2, 3 with the word, or a fraction, 1 over 3. These are the main ways you'll see it right here. We've already split our first line segment with the ratio of 3 to 2. Partition point is here. There's 5 segments in total. 3 plus 2 will tell you the number of segments. Let's do the next one. Split is 1 to 4. 1 to 4, going from A to B. They tell me direction too. If they say A to B, I'm going A to B. If they say B to A, I will go back from B to A and split it. But all these are A to B. My partition point is here. P. Total number of segments, 1 plus 4, still 5 segments. The next one, split is 2 to 3. Split here to here, 2. Here to here is 3. Partition point is here. 5 segments in total. Easy enough. Let's see if you picked up on anything. Nikita, on this one, it says determine the ratio of the directed line segment AB when partitioned by point P. They already did the partitioning for us. They just want to know what the ratio would be. And just look at it. Tell me the ratio. It should be simple.
1, 2.
Is your name Nikita? I'm recording, guys. Let's not get wild. Maram, since you want to answer for her, go ahead, buddy. The split is 1 to 2. Baram, how many segments in total?
3.
3 segments, thank you. I'm so sorry, Nikita. Let's try again. Determine the ratio of the directed line segment AB when partitioned by point P. Nikita, this one. The gaps, man. Don't count the dots. It'll throw you off. Lenoris, say it again. Oh no. Oh Jesus. We're recording, guys. Stop embarrassing me. Tristan, say it again. 2 to 3. Lenoris, 1, 2. Partition point. 1, 2, 3. 2 to 3. How many segments in total, Tristan? 5. Okay. We're going to wrap this up the right way. Nadia. The last one. I know you know. I'm trying to make sure they know. I can't hear you. Got to talk louder. Not quite. Natalia? Talk louder. 5 to 1. How many segments in total? Once you get your ratio, just add them. Alright, that's just on a simple number line. On the back, we're going to be on the coordinate plane. Give you the steps right here. Partition the line segment on the coordinate plane. Step 1. I'm going to read as fast as it's going to go over your head anyway. You ain't going to see it till I just go to the back. So I'm just going to go through them. And I've changed these steps over there. Like I said, I made this easier. I used to make the kids in the old days. I used to make them the old videos. They still online. I used to make them go on the graph, and they used to have to count on the graph, change the next, change. That's too much for y'all. I made it easier for you. You're messing up my video, McLeod. Step 1, determine the total number of parts the line is dividing into. So that's what I've been kind of prepping y'all a little bit up here, asking y'all how many segments in total. That's the first step, just figuring out the total number of segments. That's easy. After that, step 2, determine the weight to apply to each coordinate by flipping the ratio. Don't let that confuse you. All we're going to do is the ratio that they give us, when we get ready to multiply by those numbers, we're going to flip them around. Multiply each coordinate by the weight from the flip ratio and add them together. Then step 4 is determine the sum of the x and the y coordinate uh, by the total number of parts. I read that all wrong. Divide the sum of the x and y coordinates by the total number of parts found in step 1. So we're going to divide by the total number of segments we count in step 1. Don't worry about all that. Once you see me do it 2 or 3 times, you're going to pick it up. Might even pick it up after the first time. Like I said, multiple ways to do this. I'm giving you the easiest route. And this will help us tomorrow when we get into weighted average. Because we could do weighted average stuff tomorrow the same way we're doing this. Just with one less step, to be honest with you. Number 1, given points A and B, find the coordinates of the points P on the directed line segment AB that partitions AB in a ratio of 2 to 1. My ratio is 2 to 1. My first question I want to ask myself is, how many segments are there in total? Just add 2 plus 1, kids. 3. That's the number I'm going to be dividing by at the end. After that, what I've been showing you how to do this whole unit. Draw a segment so you can label it. They call the segment AB. We're going A to B. That's important. Direction is important on this. They called it AB. We're going from A to B. Sometimes we will go from B to A. Matter of fact, we're going to do that on the next one. After that, labeling. It said A was at 3,4. B was at 6,10. This is the piece that you got to do correctly on here. After you set up your segment, the ratio is 2 to 1. So when I get ready to apply this ratio to do it correctly, I'm going to flip. The one that's in the back, I'm going to apply that to my first point, point A. So in front of A, I'm going to write a 1. And I'm going to multiply by 1, that coordinate. The ratio on the back end, the B, I'm going to apply that, the first part of the ratio to that. The 2 that's in front is going to the B. Times in B by 2. This is what I mean by flip the ratio. The back end goes to the front end goes to the back. After that, we just distributing, just like we did today in our warm-up. Distribute. 1 times 3 is 3. 1 times 4 is 4. We're going to stack these in the middle because we need to add them together. On the bottom under that, I'm doing 2 times 6, which is 12. And then 12 times 2, 12 times 10, let me say that right, 20. Once we get the numbers correctly and we do the math, we add them together in the middle. 3 times 12. Nah, I'm saying this wrong. 3 plus 12. Let me slow down. 15. 4 plus 20. 24. This is me adding the coordinates together after I apply weight to each side. And then the last thing I need to do is divide by the total number of segments. Divide by 3. Divide by 3. That 3 is coming from the total number of segments that we counted at the very beginning. Doing this correctly is going to give me my partition point. 15 divided by 3 is going to be at 5. 24 divided by 3 is 8. My partition point on this line to partition it into a 2 to 1 split will be at 5, 8. If we were on a graph, I could show you that, but I didn't even put a graph on this one because I'm showing you that you don't need a graph. When we get down to number 3, I'll graph it afterwards to show you. Let's keep moving. If you didn't catch it on the first one, you're going to catch it on the second one. I promise. You don't catch it on the second one, you'll catch it on the third one. If you don't catch it on the third one, you know I'm praying for you. Given these points, A and B, find the coordinates of the point P directed on the directed line segment, BA, that partitions BA into a 1 to 2 ratio. First things first, total number of segments. The line segment is BA this time. You should draw it that way. B to A. B is at 6, 1. A is at -3, -2. After I draw my segment correctly based on how they named it, then I'm going to apply my ratio correctly. Number in the back goes to the front. 2 goes to the front coordinate here. 1 goes to this coordinate. Doing the math after I apply it correctly. 2 times 6, 12. 2 times 1 is 2. Over here we're multiplying by 1. It's going to be the same numbers. We're still adding these together though in the middle. 12 plus -3. +9. 2 plus negative 2, 0. After you do that, don't forget to do what you need to do at the end, which is divide by the total number of segments. Divided by 3, divided by 3. 9 divided by 3 is 3. 0 divided by 3 is 0. My partition point for this one would be at 3, 0. If you didn't catch it yet, got one more I'm going to show you. Catch it here. Number 3, find the coordinates of point P on the directed line segment AB that partitions the AB into a ratio of 1 to 3. On this one, I give it to you on the graph because you got to pull the coordinates off the graph. We're still doing the same thing. Let's start here. What's the total number of segments, Aubrey? Good, 4. We're dividing by 4 at the end. Down here, let's do it. They called it AB, so we're going from A to B. Drawing my segment A to B. A is at where? I don't want to read coordinates. Y'all teach me how to read them. Where's A? Negative 4 what? I agree. Where's B? 4, 1. Okay. After that, just make sure you apply the ratio correctly. What am I timesing A by? Let me say that correctly. 3. And B? 1. Alright. Distribute. In the middle here, I'm going to get negative 12, comma, negative 9. Over here, I'm just going to get 4 and 1 when I times by 1. We're adding those together again. Negative 12 plus 4, negative 8. Negative 9 plus 1, negative 8. Dividing by 4, that Aubrey told us. Negative 2, negative 2. My partition point is going to be at negative 2, negative 2. Since it's on the graph, I can show you. They told me the split was 1 to 3. So if I put a point at negative 2, negative 2, it should look like a 1 to 3 split of the line. Negative 2, negative 2 is right here. That's my partition point. And that does. If you don't believe me, I'll put the other points in. Here's one. Here's another one. This is my 1 to 3 split of that line. Negative 2, negative 2 from A to B. That's my partition point. Splitting the line. Alright. I did well. I'm proud of myself. Number 4 on this one. You're going to do this one, but let me talk. Find the coordinates of point P. The directed line segment is B to A. So, total number of segments is 4. Down here, you are doing B to A. Get point B first, then get point A. Do it correctly. That was a quick set of notes. That was cool.